Hello, everybody. Good morning. How's it going today? Today we're going to wrap up Chapter 9. We're going to talk about 9-6 today, the quadratic formula and the discriminant. Using the quadratic formula, allows you to solve any kind of quadratic equation or function. In fact, you can use the determinant from the quadratic equation to find out how many solutions you will have before even solving the equation. So we're going to deal with a lot of powerful formulas today. In order to use, or in other words, in order to solve any quadratic equation, or function in the form of ax squared plus bx plus c equals 0, you can use the quadratic formula, which is x equals negative b, so that comes from the b value, plus or minus the square root of b squared, again we're using b, minus 4 times a, that's the coefficient of x squared, times c, which is the constant of the function, divided by 2a, which is again a, the coefficient of x squared. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Remember, gentlemen, that it is an x equals because, in the end, when we're graphing here, the solution of any quadratic function or equation are the x-intercepts, or that's if there's 2, or the x-intercept if there's 1, and if it never touches the x-axis, it'd be no solution. Okay? But that's why it's an x equals, because we're looking for the x value when y is 0. We're looking for the x-intercepts. Okay. Let's put it to use, my friends. What are the solutions of, we got a, 2x squared minus x equals 4. Well, the first thing we want to do is turn this into a trinomial. Always remember that when we're dealing with completing the square or factoring or any of the methods to solve a quadratic function, we're dealing with the function y equals ax squared plus bx plus c. So we're going to have everything together on one side, forming a trinomial. So I'm going to subtract 4 to both sides with that in mind. And I've got 2x squared minus x minus 4 equals 0. Well, let's do this. Let's first label our values. A is 2, B is negative 1, and C is negative 4. So I'm going to go ahead and plug in my formula. Remember, the formula is negative b plus or minus the square root of b squared minus 4 times a times c, all of it divided by 2a. So I'm going to have negative b, so a negative times a negative, we're talking about negative b, I'll do it nice and slow this first time, plus or minus the square root of b squared minus 4 times a times c, all of it over 2 times a, which is going to give me 1 plus or minus the square root of 1 plus 32, because negative 4 times 2 is negative 8. Negative 8 times negative 4 is 32, so 1 plus 32 is 33 over 2 times 2, which is 4. You cannot simplify this any further. You're done. If you could simplify this radicand, you must. You have to. But in this case, you don't, so you are done. You have two solutions here. You have 1 plus square root of 33 over 4 and 1 minus square root of 33 over 4. Okay, let's continue, gentlemen. Letter B. Please notice, if I had just said to you, solve, just in general, solve, I would not use a quadratic formula here because this is factorable. This factors out to be x plus 3 times x plus 3. Zero product property, x plus 3 would equal 0. Subtract 3 to both sides, x equals negative 3. That's going to be our answer. That's what I would have done if it just said solve. But please remember, I asked to solve by the quadratic formula. So we're going to have to actually do it the long way. A equals 1, B equals 6, C equals 9. Perfect. Negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. In this case, it's going to give me negative 6 plus or minus 36 minus 36 over 2, which gives me negative 6 plus or minus the square root of 0 over 2. The square root of 0 is just 0, so negative 6 divided by 2, x equals negative 3. We knew that already, but that's how it works when you use the quadratic formula. You can use the quadratic formula to solve any quadratic equation or function. Okay, for letter C, again, we got to turn this into a trinomial first. So I'm going to add 4 to both sides. I've got x squared plus 4x plus 4 equals 0. A is 1, B is 4, and C is 4. So I'm going to go ahead and use my quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c, all of that divided by 2a. So this will give me negative 4 plus or minus the square root of 16 minus 16, all of that over 2 times 1, which is 2, which is going to give me, remember, square root of 16 minus 16, that's 0, so that cancels. So I have negative 4 divided by 2, so x equals negative 2. That is the solution. Let's do one last one. Okay, I've got x squared plus 4x minus 3 equals 0. It's in trinomial form. Let's go ahead and label and solve using the quadratic formula. A equals 1. B equals 4. Sorry, that's a little bit of an ugly 4. And C equals negative 3. So let's go ahead and use our formula. Negative b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. So it's going to give me negative 4 plus or minus 16 plus 12 here. Negative 4 times negative 3 is negative 12. So 16 and 12, that's going to be 28 over 2. I wish I could say that we're done, but remember what I said the first time when we did our first example. If I can reduce the radical, if I can simplify it rather, I have to. So 28 breaks up into the square root of 4 times the square root of 7. And we all know that the square root of 4 is 2. So this breaks up to be negative 4 plus or minus 2 square root of 7 over 2. Please remember that this 2, it's a division distributive property. So it divides to the whole numbers. And my final answer would be negative 2 plus or minus square root of 7. And you're done. That's the quadratic formula. Pretty simple. No matter how nasty the numbers are, we can always use a quadratic formula. That's why they invented it. It's pretty powerful stuff. Now let's move on to the discriminant. What is so special about the discriminant? Well, the discriminant of a quadratic equation or function in the form of ax squared plus bx plus c equals 0 is the value of the expression b squared minus 4ac. And I have b squared minus 4ac. That value is the discriminant. B squared minus 4ac. That alone is going to tell you whether you have 1, 2, or no real solutions. Okay? It's the radicand part of the quadratic formula. That's the discriminant. And how does it help us? Well, discriminant helps very, very, very easily. If the discriminant, b squared minus 4ac, is equal to 0, that means that there will be only one answer, one real solution. And as you can see here, that means you have one intersection, one x-intercept when the discriminant is equal to 0. When b squared minus 4ac, the discriminant, is greater than 0, you're going to have two real solutions. Okay? And that means that you're going to have two x-intercepts. That means the graph is going to intersect the x-axis twice. And that is when and only when the discriminant is greater than 0. If the discriminant, b squared minus 4ac, is less than 0, it's a negative, you will have no real roots. You're going to have no real solutions. So that means that the graph, as you already know, will never intersect the x-axis. Let's practice. What is the number of real solutions of each equation? Well, let's check this out, guys. Like always, let's label. A equals 2, B equals -3, and C equals 7. So, let's find the number of real solutions. I'm not asking to solve this. I'm not asking what are the solutions. I'm asking how many solutions are there. So, it's b squared minus 4 times a times c. So, b squared is -3 squared minus 4 times a times c. This is 9 minus 56. 9 minus 56 is going to be negative 47. Negative, well, when b squared minus 4ac is less than 0, there are no real solutions. So there are no real solutions for A, because the discriminant, the b squared minus 4ac, is less than 0. It's a negative number. For B, just like always, we have to turn it into a trinomial. So I'm going to subtract both 6x and 5 to both sides. So I've got x squared minus 6x minus 5 equals 0. My A is 1, my B is -6, my C is -5. Let's see how many solutions we have. We're not solving, we're just determining how many solutions do we have. Well, B squared is 36 minus 4 times A times C. That's 36 plus 20, which equals 56, which is positive. So there are two real solutions for example B. Hope that all makes sense. Now, let's put solving quadratic functions all together. You have learned several ways to solve the quadratic functions and equations. When do you use each method? That's the question. When do we use each method? Well, let's start with graphing. I would say that you're absolutely never going to use graphing to solve. I can tell you graph the equation, and then you find the axis of symmetry, which is negative b over 2a. You find the vertex, which is negative b over 2a, comma, the y value when you plug that negative b over 2a into x. Then you find the y-intercept, and then a test point if you have to, and you graph it. Sometimes you see the solution very easily on that graph. Sometimes it's very difficult. So graphing, it's good to see the shape of the parabola that you have, see the shape of the quadratic, but it's not really good for solving. So you use the graphing method to solve when it's very easy. And by very easy, I mean something like y equals x squared. Why would that be something easy? Because the axis is 0, the vertex is 0, 0, the y-intercept is 0, 0. So you just use a little table method, and your point's going to be 1, 1. And that graph would look like this. Here's 1, here's 1. It's going to look just like this. So in that case, the solution would be x equals 0. If it's something simple like that, and you only have an x squared value, you don't have any constants, you don't have a bx value, if you want, sure, you can go ahead and use the graphing method. Still though, even if it's like that, I would have used the square root method and done it a lot quicker. So you can solve by graphing, but I would rarely recommend that. So graphing is pretty much just good for seeing the shape of the graph, seeing what the quadratic looks like, estimating the solutions, but not really solving, in my opinion. Square root method. Absolutely, you use the square root method when the equation does not have a bx term. If I have x squared minus 11 equals 0, that does not have a bx term. I'm going to add 11 to both sides. Then I'm going to have x squared equals 11. I'm going to square root both sides, and x will equal plus or minus the square root of 11. And I just solved it. Done. When you do not have that bx term, go ahead and use the square root method. It's going to behoove you. It's going to benefit you greatly, and you're going to get to the answer a lot quicker. The factoring method. Well, if you can factor it, factor it. Okay, it's that simple. If you can factor it regardless of the method, regular method, grouping method, if you have to factor out a GCF, Cuban method, the column method, if you can factor it and you can turn it into the product of binomials, then do it, because then you could use the zero product property and you're good to go. Number 4, completing the square. Use completing the square if the equation is not factorable and the a is equal to 1. So for example, if I have x squared plus 2x plus 9, that is not factorable and the a is a 1. Remember that the a is the coefficient of x squared. The a is the number being multiplied to x squared. So if it's not factorable and the a is equal to 1, go ahead and complete the square. And last but not least, number 5, you're going to use the quadratic formula if the trinomial is not factorable again, but this time the a is greater than 1. If I have, for example, 2x squared plus 7x plus 3, I'm not even going to try to complete the square there, because I have to subtract the 3, then I have to divide by 2, then I got to complete the square, and you're going to have a lot of nasty fractions. In that case, directly go to quadratic formula. And just so you know, if you get to a situation that you cannot factor, okay, and you really like the quadratic formula, you can use the quadratic formula, given that they just tell you solve using any method. If they tell you solve with a specific method, then you must solve according to that method. Okay? But you can use quadratic formula in a pinch for any quadratic equation. Remember that. But the most useful common use for it is when it's not factorable and you've got an a that is greater than 1, or you have a bunch of nasty numbers like fractions or decimals. That's when for sure you go to the quadratic formula. All right, guys, let's see if we can put this together now. Which method would you use to solve each equation and why? Okay, instead of me explaining why, I'm just going to go ahead and solve it for you, okay? Well, for this first one, I'm going to go ahead and divide everything by 3. So I have x squared minus 3 equals 0. I do not have a bx term here. I do not. So I'm going to go ahead and use the square root method. I'm going to add 3 to both sides. So it's going to give me x squared equals 3, square root both sides, x equals plus or minus the square root of 3. Those are my solutions, and I did it by square root method because I did not have a bx value. That's when I use the square root method. Number two. Number two may or may not be factorable. You'd have to multiply a times c to find a new c, and that's going to be 102. That's a large number. That's going to be a lot of time consumption, a lot of thinking. I want to get to the answer. So in this case, I'm not going to complete the square, but I am going to use the quadratic formula. A is 6, B is 13, and C is 17. So negative b plus or minus the square root of b squared, 13 squared is 169, minus 4 times a times c over 2 times a, which is going to be 12 because a is 6. Okay, so let's see what that gives me here. That's 24 and 17. 24 times 17 is 408. So wait a second. This is going to give me negative 13 plus or minus. And I've got 169 minus 408. That gives me negative 239 over 12. Guess what? This should raise a red flag. I cannot have a b squared minus 4ac that is negative. So right here, no real solution. There's no real solution there, gentlemen. Done. Awesome. Okay, next, number 3. With the size of these numbers, I'm going to absolutely use the quadratic formula. A is negative 16, B is negative 50, C is 21. So, negative b plus or minus b squared, which 50 squared is 2,500, minus 4 times a times c over 2a, 2 times negative 16. This is going to be 50 plus or minus, you got 4 times 16, which is 64, times 21, which is 1344. And a negative to the negative is a positive. So 1344 plus 2,500 equals 3,844 over negative 32. Does that make sense to everybody? Okay, good. And that's it. That's my answer. We could probably reduce this. Not probably, it's for sure. But I'm on a little bit of a time crunch. So we'll reduce that on a test or a quiz. But that is how you would do that. And I chose the quadratic again. Why? Because it wasn't factorable and I had an a that was larger than 1. Okay, for number 4, this is factorable. This factors out to be x minus 6 times x plus 5. Negative 6 times positive 5 is negative 30. Negative 6 plus 5 is negative 1, so it works. Now I activate my zero product property. So x minus 6 equals 0. X minus 5 equals 0. So my solutions are x equals 6 and negative 5. Number 5. Well, I could use completing the square, or I could use a quadratic formula here. It's not factorable, and my a is 1. So I could use the completing the square, which I'm going to go ahead and do it. I subtract 3 to both sides, so I have x squared minus bx plus, I have to complete the square, so that's b over 2. So negative 5 over 2 squared equals negative 3 plus negative 5 over 2 squared. I'm going to drop this down this way, guys. X squared minus 5x plus negative 5 halves squared. That factors out to be x minus 5 halves squared equals negative 3 plus 25 fourths. That denominator goes to a 4. That goes to negative 12. So I have x minus 5 halves squared equals 13/4. Square root both sides. X minus 5/2 equals plus or minus square root of 13/2. Add the 5/2 to both sides. And I have x equals 5/2 plus or minus square root of 13/2. Now, could I have plugged that into the quadratic formula? Absolutely. Would I have had the same answer? Absolutely. Why did I choose completing the square? Well, because it's not factorable and the a is a 1. You don't have to complete the square there unless they tell you solve by completing the square, but that is one of the options. You could have done it by quadratic formula as well. I want to make sure you guys got that because I got to erase that now. Last but not least, hopefully you're recognizing, hey, wait a second. Let's first of all get everything together. So I've got 144x squared. Oh, wait, we don't have to do that, right? No. Why don't I pay attention? There's no bx form here. So let's solve for x. Divide by 144. X squared equals 49/144. Square root both sides. X equals plus or minus 7/12. So x equals 7/12 and negative 7/12. Again, I used the square root method there because there was no bx term. Thank you so very much. God bless you. Homework is valid and have a great day.